Hey Prime, say hello. Hi there, my name's Keegan Neeb of Neeb Engineering, and I'm here today to talk to you about the arms of MacFeegle Prime. So for those who aren't familiar, I'm a robotics engineer. I'm part of the PyWars program. That sounds a bit more Avengers than anything, if only. But no, part of the PyWars competition. So the idea is to build a robot based around a Raspberry Pi, which in my case sits up in his head, and compete in a bunch of competitions. Now, I quit my job in December to take up this full time to actually change my career in the direction of becoming a robotics engineer, and I have. And yeah, so if you want to support me, the best way to do that is honestly through Patreon. Link in the description, but that's patreon.com/neebeng. And yeah, that would be the greatest help. If not, if you could just subscribe to this page just to keep track, that will help. Sharing is caring, and in the days of feeding the beast, which are the various algorithms, sharing is king. So, yes, that out of the way. This is MacFeegle Prime. So this is somewhat influenced by Johnny 5, as you can tell, more so those who've been following for a while. And yeah, the arms, both of them, are actually working. Now, this whole robot is a work in progress. I've been working towards what is referred to as the MVP, the minimum viable product. So I'm very close to the point where I can actually use the two cameras in his eyes to send imagery through to my custom controller based around a Raspberry Pi. So I could manually and remotely actually compete in all of the challenges and get some points. Now, I'm in the advanced category for PyWars, so the fact I'd be doing it all manually means I'd be, in line for the lowest number of points and wouldn't be competitive with people in my group. But it's working. We've got control over both the arms. He can do the chicken dance. It's locked down. I'm allowed to be mad. I mean, I was mad beforehand, but that's. Don't you look at me like that. You know I was mad. I created you. Oh, the descent into madness. As soon as he can start to talk, no doubt he'll start talking back, but that'd be fun in itself. So, yeah, the arms. I have no idea where I was going with this, but I never do. The kind of the big point for this is to go completely over the top, and in that I've succeeded. So the arms are realistically only needed for one challenge in this year's competition, which is PyWars 2021, which is tidy up the toys, just sorting 3 coloured blocks and putting them in a pile in the corner. In the 2020 competition that should have been, which is now postponed to next year, the disaster zone competition, it would have been sorting 2 colours of barrels. You could just do this with a gripper or even just a plough on the front that you can push the tracks around, but I decided this would be a fantastic excuse to build something completely over-engineered. To that end, we have arms that have the same degrees of freedom as humans. So each of these arms have 7 degrees of freedom, and what that means is that we've got 7 ways in which the robot can move his arm, 7 joints. The same we do. So we've got, I think that's transverse, that's sagittal. I've been trying to learn the real words for this, but anyway, forward and backwards at the shoulder, inwards and outwards at the shoulder, rotate at the shoulder, and then you've got the elbow. It can rotate there as well at the wrist, and then the wrist itself can go left and right and up and down. So if I've done that right, you've got 1, 2, 3 rotating, 4, 5, 6, 7. There we go. I thought I'd lost one for a second, but I always do. And the robot is no different. So I'll talk a bit more about the actual controls and how I'm controlling this in more detail in the next video. This one is more of an overview of the robot itself. So we have what I refer to as the flappy axis, because like I said, I'm still learning the right words for these things, and that's not working because I need to put it into arm control. So we've got in and out on both of these arms, and I'll just carry on with the right arm because it's easier. So yeah, that's 1 degree of freedom in the in and out, which I refer to as the flappy axis. We then have backwards and forwards, and can rotate, oh no, in, and then we can rotate left and right. Now, we've got 3-axis joysticks, which means we can control 3 axes. They've also got a button on the top, so I'm using that as kind of like a shift, a modifier key. So if you press and hold that, and then press down and up, he then controls the elbow, and left and right still controls that one, because this is more about the design, the use of it than anything. But if we rotate it, it rotates there. Now if we go into hand control mode, which gives us more fine motor control, and press the button again, we can actually rotate it to open and close the hand, and then if you do left and right, the hand itself will raise and lower. And yes, I have one of the barrels from last year's competition. If we open his hand up, whoop, we can actually close around it. I think one of the things has gone, and there we go. We have the controls aren't exactly intuitive at the minute, but yeah, there you go. I'll bring it to the camera. And again, I'm going slightly mad, but yeah, so that is the control, and drop. There we go. And right now, as you can see from the kind of jerky movements and the fact you can hear me flicking switches and things like that, it's quite manual process at the minute, so controlling each of the joints individually. Now, that's all well and good for now, but what I'd really like to do, rather than saying, okay, shoulder move up like that, elbow move out like that, rotate the wrist like that, open the hands, and so on and so forth, which if we had to do that ourselves, we wouldn't be able to breathe, never mind walk. I want to get to the point where I can just say, right, hand move forwards, and it will move forwards in X, or up and down in Y, and you can rotate it and all the rest of it, and the software in the robot will just take care of that. That is something called inverse kinematics, and the kinematics is basically the control of movement. So in this case, we're saying move, change angle here, or just like add value to servo current position and move and rotate, and that's all we're doing for all of that. It's just kind of a brute force process in that regard. But what we could do with inverse kinematics is, rather than thinking about it in terms of the angles, all we're doing is telling a controller, move end of arm to XYZ position. So it'll go there, 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 or there, or whatever you want it to be. And it will change, it will calculate the positions of the servos that are required to get you into the arm into the pose, which is how it all ties together. That's something we're going to start working towards in future videos, and we're going to use the Move It library, which is part of the robot operating system, but in the first instance you need something that works, and we now have that, so we can actually progress at hopefully quite a speed. Now, it does work. There are improvements that could be made. So for one thing, the fingers have no real grip at the minute. The only reason it could hold this is because it's ridged. So it just basically, ooh, careful. Let's disarm that. No pun intended. But yeah, so we need some kind of actual grip to make it be able to pick things up easier. Now at the minute, this hand actually has dabs of hot glue just to kind of give ridges. It doesn't really work, but it was worth a try. So that needs improving. Now I can print in rubber using TPU on my printer. So what I can do is either print a first layer of TPU and then change filaments and carry on printing on top of that to have a dual filament going. I'll need to get a different type of filament to do that for various reasons, but basically the flexible filament doesn't stick to PLA, which is what I've used everywhere. And it really sticks to PETG though, so I can just do that. I just need to do it basically. So that's one of the things. Another big thing is backlash. Now, there's a lot of movement in these joints. I mean, especially in the flappy axis. I mean, the servos aren't even trying to fight back at that point, which means that that's just all slack, and you can see the hand wobbling around. And it's the same on this side. Now, that is basically, as I've been going, I've been learning, and I've learned an awful lot, because I've made an awful lot of mistakes, because that's how we learn. And yeah, so basically I just need to kind of go through and just tidy up the design. And a lot of these holes, they've got rods going through them or bolts, and the spaces are just too big, so it's just there's no tightness to it everywhere, and every little bit of slag adds up to the point where things can move around to that degree. He's clearly not happy with the poor quality of his joint there. Anyway, and yeah, but the slackness holds true everywhere else. Now the servo down here that lifts up his torso, it's connected but not currently doing anything, because again, that design for this torso linkage isn't great. It's all slack basically, and that needs to be redone. The original plan was to put some bearings in there, and that never really happened. But yeah, the basis of the robot is solid. No pun intended. Like, it works, you know. The difficult bits have done. It's just the fiddling to go through it and get it working better. So that's what I'm going to be doing moving forwards, and yeah, that's where we're at now. So the next video we'll be doing will be based around this controller and dropping the barrel, which thankfully, you know, this isn't disaster zone and that isn't toxic waste. So that giving more details on this, which is it is plugged into power at the minute, but it's literally a USB battery bank. It has a pipe juice hat in there, so it is self-contained. It's just the battery doesn't last that long because it's got a full pi in there, and a Teamc running to control the various joysticks and switches and things. Now, I will go into details as to how this is calibrated and how the control mechanisms actually work from a software perspective, and giving a bit more detail there. But yeah, until then, please stay tuned, subscribe, like, do all the things you usually do with YouTube posts to feed the beast, as I've said. And if you are able to support on Patreon, that would be a great help. You'll basically, there's £1, £5 and £15 subscriber levels, and from £5 and up you get early access to these videos up to a week early. So I'm going to bring that forward a bit to give a bit more of a benefit there. But like I say, if you just share these videos or like the posts, it's going to make it more likely that other people will see them, and that will all help in the long run. So thank you for watching if you got this far, and see you next time. Bye for now.